We were talking about the PCB of a Panasonic 1.5-ton air conditioner, and I have already explained a lot about it to you. If you haven't watched that video yet, you should check it out. It will give you a clear understanding of how the functions and systems work and what purpose all these wires serve. Now we will understand how its SMPS system works. This is the rectification section, which is the input point where electricity comes in. However, there are additional components connected here, and I will explain those to you as well. First of all, there is a fuse installed. If for any reason the fuse blows, you should replace it. This is a 7.4 ohms power resistor. It is used to protect the power supply and circuit components from high inrush currents when the outdoor unit is powered on. A viewer had asked what SMPS stands for. It stands for Switching Mode Power Supply. After this, the power supply goes into the rectification stage, where it is converted from AC to DC. Look here, after being converted to DC, this becomes the negative point, and this becomes the positive point. When the negative and positive sides are complete, there is a filtering capacitor connected here. This capacitor is rated at 56 microfarads and 450 volts. This small capacitor filter out voltages spikes for the SMPS. We get 320 DC volts here on these capacitors. These voltages are then directly sent to the positive side, which in turn goes directly to the chopper. As I showed in a previous video, there is a diode connected here to ensure protection. If a short circuit occurs, this diode will open and the entire system will shut down. This diode is placed here to protect the system from damage. Now look, the pins of the chopper will function only when its switching IC is working. Let me also share the number of this IC with you. The IC is STR152, and you can check its datasheet for more details. Look here, this is pin number 1, which is the drain pin. During switching, the neutral point connects to the MOSFET through this pin, and the MOSFET turns on the chopper. Once the chopper is activated, it starts generating voltages on this side. Now let's talk about pin number 3, which is the source pin. Its neutral point is connected here. This is where all the neutral points come together, and from here, the negative point is generated. It travels through this path and reaches this point. Between these points, there is a resistor, which I'll show you as well. This is the 1.2 ohm resistor. If this resistor gets damaged, the SMPS will also stop working. Now let's talk about pin 4. This pin performs two functions. 1, it generates the feedback voltage. It provides the VCC to the IC, and the voltages generated are used for feedback purposes. Next, let's discuss pin 6, which is the feedback pin. Where does this feedback come from? When the chopper turns on for a while and starts generating voltages, the optocoupler gets activated. Let me show you the optocoupler used here. It's labeled PC6. This optocoupler manages feedback and sends it to the IC, stabilizing it. This is how the function is completed. Lastly, the startup pin is used to measure the current voltages to detect any issues. If a problem occurs, it shuts the system down. Additionally, pin 5 serves as the ground. When the chopper turns on, voltages start generating on the low side. Let me explain the points and the voltages that should appear there. In most Panasonic models, the company has clearly labeled the voltage values point by point. Let me show you. 15 volts should be present. The company has explicitly mentioned that if 15 volts are available here, all the 15 volt related functions will work properly. At the next point, 13 volts should be present. Moving further, at another point, 8 volts should be available. These are used to activate the voltage regulator to produce 5 volts. The company has marked that 4 volts should be present at another specific point. These voltage points ensure the proper functioning of the system as per the design. Now let's discuss where these voltages are used. 1, 15 volts. These are used to operate the DC fan motor and the IPM. 2, 13 volts. These are used to operate all the relays in the system. 3, 8 volts. As mentioned earlier, these are used to activate the voltage regulator. 4, 5 volts. These are used to operate the microcontroller and all the small ICs in the system. Each voltage level plays a specific role in ensuring the proper functioning of the respective components. Now, I've explained several points to you. In the SMPS system, the most common issues occur with the switching IC, which can get damaged. Additionally, safety resistors and diodes can also fail, or the chopper may become faulty. If all the required voltages are present, the system will operate properly. However, if any voltage is absent, it indicates a fault in a component, and the PCB will not function. Regarding the high side, I've already explained that the first rectifier should have 230 volts present. These 230 volts will not be filtered out unless the system is functioning properly. The filtered voltage will be available at the rectifier on the high side, where you should measure 230 DC volts. This is how the system performs its function. Now let's talk about its communication circuit. The red wire is the communication wire, and its circuit is connected here. This is the communication circuit, and I'll show you the components from the other side as well. You can see the optocoupler and diodes, among other components. These are used to enable communication at this point. If this circuit does not work, the communication will fail. Additionally, this circuit here is designed to drive the IPM. For turning on the IGBT, two optocouplers are used. If these optocouplers stop working, the IGBT will not function, and consequently, the IPM and the compressor will stop working as well. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.